So, welcome to the next lesson in the course around direct current, and that is the final of the series on resistance. So today's lesson, we will identify that an increase in resistance will reduce the electrical current, explain how the resistance of an LDR or light dependent resistor and thermistors change with light intensity and temperature, and calculate resistance in parallel and series circuits, and finally determine Ohm's law. So which of these materials would have the highest resistance? So from our experience, you would have to say that it would be wood, because remember in year 7 wood is known as an insulator, whereas metal is known as a conductor. So it's easier to pass electricity through metal than it is wood. So resistance is anything that will resist the current going through the circuit. So for example, it would make it harder for the electricity to flow. So it's measured in the unit ohms, that funny symbol there, and has the symbol R. Resistance in a wire depends on a few things, known as the resistivity of the wire. It's based on the length of the wire, so the longer a wire, the higher the resistance in the wire. The cross-sectional area of the wire, so the larger the cross-sectional area, the less resistance there is. And finally, the type of metal the wire is made of. So, for example, copper wires have less resistance than iron wires. And there's a diagram illustrating that point there. The bigger the resistance, bigger the resistivity. So twice the area, half the resistance, and twice the length as twice the resistance. Okay, so here's a section of words. I want you to fill in the gaps. So pause the video now and come back and let's work through the answers together. Okay, so welcome back. Let's go through this now. All components in electrical circuits have resistance. Okay. Even the wires. Some components, like the bulbs, which we're all familiar with, have a high resistance. The thin wire in the filament makes it harder for the current to flow. Okay, so we make our filament. Putting more bulbs in series will increase the resistance and decrease the current. So moving along, measuring of small currents. So what we use in the laboratory is something called a milliammeter, because they deal with really small currents in the milli range, and they must be placed in series. And they need to measure the current flowing through the system, just like normal ammeters would. Okay, and they are very sensitive, and they determine the current, small amounts of current flowing through a circuit. So if you look at the resistance for a component and measure the voltage and the current for that component and change the voltage and or current, well, actually change the current, you get a plot of voltage versus current. Okay, and this graph shows that because it's a straight line relationship, it is directly proportional to current is directly proportional to potential difference. So current is directly proportional to the voltage. For example, if you double the potential difference, the current doubles. So here we go, you go 1, go across, it's about 0.75, 2, it's going to be about double that, about 0.125. amps. This is known as Ohm's Law. So here we have that graph again of resistance, voltage versus current. So the general equation is a straight line graph, y equals mx plus c, where y is the voltage, current is the x value, of course units of amps, and the gradient, which is going to be the change in voltage over the change in current, is going to equal this magical value of resistance. Therefore, phi equals IR, which is, of course, Ohm's law. So here we have a series circuit, and it has three different resistances. It has a resistance of 4 ohms, a resistance of 3 ohms, and a resistance of 2 ohms. And if you develop this experimentally and determine the resistance of the whole circuit, you will find that the total resistance will equal 9 ohms. Okay, so for this, the total resistance for a series circuit, for this one anyway, is going to be 4 ohms plus 3 ohms plus 2 ohms, which equals, of course, 9 ohms. So here we have a parallel circuit. So if we, and with three resistances, it has 2 ohms, 3 ohms, and 4 ohms. And if you actually measure the resistance, the total resistance equals 0.2 ohms over the entire circuit. Okay, so what that actually says is that the R total equals 1 over, let's get slightly complicated, 1 over 1 over 2 plus 1 over 3 plus 1 over 4, which equals, of course, 0.02 ohms. So the difference between series and parallel is that in series, the more resistors you add, the higher the overall resistance, whereas in parallel, conversely, the more resistors you add, the less the resistance in the total circuit. And there we have the equations. So in resistance in series equals R1 plus R2 plus R3, continuing on, whereas in parallel, resistance is 1 over R1 plus 1 over R2 plus 1 over R3, continuing on. Okay, so here's a few questions to test your understanding if you've actually comprehended Ohm's law. So what is the resistance of the following? A bulb with a voltage of 3 volts and a current of 1 amp, a resistor with a voltage of 12 volts and a current of 3 amps, a diode with a voltage of 240 volts, a current of 40 amps, and a thermistor with a current of 0.5 amps and a voltage of 10 volts. Okay, so let's just rearrange the equation. V equals IR, so resistance is going to be voltage divided by current. Okay, so a bulb with a voltage of 3 volts and a current of 1 amps, just plug in the numbers, it's going to be 3 divided by 1, which equals 3 ohms. A resistor with a voltage of 12 volts and a current of 3 amps, so it'll be 12 divided by 3, which will be 4 ohms. Diode with a voltage of 240 volts and a current of 40 amps will be 240 divided by 40, which will be 6 amps, or 6 ohms, sorry. And thermistor of a current of 0.5 amps and a voltage of 10 volts, so it'll be 10 divided by 0.5, which will be 20 ohms. Right, so that's resistance applying Ohm's law. Next, we're going to see what happens when Ohm's law breaks down.